Hey there, today we'll be doing this question that appeared in Leetcode Weekly Contest 3342576. Find the maximum number of marked indices. Given question statement is you are given a zero index integer array nums. Initially, all of the indices are unmarked. You are allowed to make this operation any number of times. That is, pick two different unmarked indices I and j such that 2 into nums of I is less than equals to nums of j and mark I and j. And we need to return the maximum possible number of marked indices in nums using the above operation any number of times. So let's understand this problem statement better with this example right here. So I've already pre-written this one. Let's see this one. So they have said that we've got to choose such indices that is I and j. And remember, the I and j can be in any order. That means your I can be here and your J can be here. There's no such restriction on your I should be lesser or J should be greater. There's no such restriction, so you can do that. And also, they have mentioned that they do not care about the positioning of the nums of I value and nums of J value. It can be anywhere, right? So, what can we do? We first of all sort this. This might have already come to your mind that we should first of all sort it. In these types of question, whenever you're getting something that is you have to choose some indices and the positioning does not matter. That is, they have not said that a condition I is less than j matters. Whatever is there, you should just first of all sort it and then think about okay what to apply in this part. Now coming on to the next part, 2459. Here we see that we can choose for this 2. We have got multiple options, that is this 4, this 5 and this 9, right? Since we have to choose a value 2 into nums of I, and nums of I is how much? 2. So we can choose all the values which are greater than or equals to 4, right? This is our bound. We can choose all the values greater than equals to 4. Now we have three options, that is 4, 5 and 9. What are we going to choose? You might think that we can choose any. There's no problem in choosing anything, so let's just choose the first one. This is where we can go wrong. And why so? Because if we choose, let's just say, the nearest greatest one, or the one which we can actually choose, still we are having more two options, but we chose the nearest one. That could actually lead us to a wrong answer. And why so? Because this one right here could actually make a pair with someone else, right? Can actually make a pair with someone else. That is 4 into 2, 8. I can have this paired up with this guy right here if I have not chosen it, obviously. But since I've already chosen it, what will happen? The possibility of actually choosing this 4 and pairing it with someone else has gone. Now, what do we have? So, first of all, we have paired this 2 and 4. Now, we can't do anything about this thing, right? Now, we move on to 5. Now, let's see. So, when we come on to 5, we see that, okay, now what is the minimum value that we need? That is 2 into 5, that is 10. We need at least a number 10 in order to make a pair it with someone. It can be greater also, but we do not find it in our array. Now this is the part where we need to actually understand the intuition. That is, we have to make sure we pair it in such a manner such that all the elements which are coming to the right of me are actually getting a paired with someone else. That means if we are making sure that we are pairing this guy with the nearest one, remember, whenever we go right, the number will obviously increase. And what do I mean by that? Let's understand that part as well. So for every pair, let's just say this is my nums of I right now. What do I need? I need 2 into 2, that is 4, if I want to make a pair. If this is my I need a value 8. If this is my I value, I need 10. If this is my I will need a value 18 in minimum to make a pair like this, right? So as you can see, we have already sorted the array. So whenever we are going right, we see the values are increasing. So my chances of getting a pairing with this higher value will become less and less, right? See, let's just understand this better again. If you just get this point, you will be able to actually go this problem in one go. That is, if I am having a smaller number, my chances of getting this value will be much more than the number I'm having on the right, obviously, right? Because all the numbers which occur greater than this exist on my right. So I'm having more elements on the right, obviously. So the chances of getting a smaller number's value is obviously higher than this guy's and also this one's, right? So this is where the greedy nature of picking elements come into place. That is, we'll be trying to divide it in such a manner such that we are having equal opportunities. That means here we are having the length of the array as 4. So how many pairs can we find? We can form at most n by 2 pairs, right? Let's just say this is one of the pairs and this is one of the pairs, right? So this is one of the pairs, but it is not actually one. But we just took an example. Even if it's odd, then also it is n by 2 only. Okay. So this is the part where we get to know, okay, how many pairs we have. So right now we know that there is at most 2. Fine. So what can we do? In order to actually maximize it, what are we going to do? We are going to actually split it in half. That means at the right half we'll be having all the small numbers, at the right half we'll be having all the bigger numbers. Now this can also be the case, that is we have some repeated numbers, this can also be the case, but still we are only going to divide it in half. Now this might confuse, why only divide it into half and why not something like this? Because see, if we try to divide it in something like this, then there would be a problem. And why? See, here we are trying to split and make pairs, right? If one of your guy is having just two and the other guys are having this, how are you going to make such pair? I can only make this pair, okay? And your iterations could be becoming more complicated, so that is why we try to divide it equally, such that we can use a two pointer approach and we can actually find it in easier manner. So let's start with a two pointer approach, how that can help us to find the answer exactly. So at first, I know this is my half, so I can put it right here, and I can put this at the end of the bound. Now I know these are my guys, and this is one of the pointer, and this is one of the pointer. Now let's just start beginning our iteration. Now what is the minimum that this guy requires to make a pair? It requires 8, and we see my last pointer, my second pointer, is standing at a value which is greater than 8, so I can make a pair, that is 4 comma 9 can be made a pair, right? So this is done. Now we can move our pointers to where? To this. Will decrement by 1 to both of the pointers if we actually make a pair. Can we make a pair? Yes, we can make a pair. 2 and 5 can be made a pair. So this is also done, and we just simply move on. Now let's just take another example, that is if we have something like 4 right here. Okay, we have something 4 like here, then can we make a pair? Now we are standing here, obviously we can make a pair. Again we'll move on and we'll come on to this part and we can again make a pair. Now let's take an example wherein we cannot make a pair, something like that. So let's just take some higher value, that is this is 4, and let's just take this as 4 again, and let's just take this as something like 6 3. So now we can see that if I'm standing right here and this guy, we can actually make a pair definitely. So we just move on. Now when we come on to this part, we see that we are not able to actually make a pair. We are not actually able to make a pair. So what do? We just make sure we remove the pointer from here and we go on to the next round. Let's just say our array is right now 1 3 4 4 and 9, that is we have odd number of elements right here. Then what do? If we have odd number of elements, what do? So this is the last part where we get to understand what do we do when we have odd number of elements. We just equally divide and we just keep this bound right here. So this is the part. We just do the same iteration. If you get a pair, that is if you get the minimum guy, that is 8, which is needed, just make a pair, and your I and j pointer both will decrease by 1. So j pointer will come here and I pointer will come on here. This is the part where you do. Now 3 requires how much? It requires at least 6 to make a pair. So can you make it? Obviously not. You cannot make it. So remember, what do? We do not say that the j pointer, you move one by one. We do not say that. We say I pointer, you move back by 1. And why so? This is the most important part, because see, for 3, if I cannot make a pair right now, wherever j is standing, if he cannot make a pair with wherever j is standing, can he make a pair with anyone to the right of it? Obviously not. Why? Because j has moved here if and only if all the elements from the right were made a pair, right? That is why j is standing at its current position. Otherwise j would have never moved to this point. At this point j has already made all the pairs that he can with all the rightmost elements. That is why he's standing here. So there's no point in moving j. J will stand at its position and only I will move, right? And I moved here. And can I make a pair right now? Yes, it can make a pair, and we are done for it. And that is it for this one. Okay. So remember, whenever we are making pair while we are moving I and j, so how do we identify that okay, this pair has already been made? Like I know 9 has already been made a pair, okay, and 4 was not made a pair. So if I come across, let's just say j is right here, j moves to here, okay. For just an instance, let's just believe that j somehow moved to this part and I is standing here, right? But let's just say this guy was already made a pair with someone, okay. This guy already made a pair with someone else. But how do I know that? Okay, can I use this element or not? So we'll just make sure that whenever we have made a pair with someone, we'll just mark that element as -1. Okay, so this is one of the things that we can do. Obviously there can be many ways, but I've just done this one. We can just change that element to be a -1 so that we can say that okay, this is not usable for you to make any pair. Okay, so this is it for the whole explanation part. Let's get on to the code part and you'll be ready to go for that. So this is the code part. It might seem very crazy, but it is not. So all you have to do is just sort the array at first. We have just sorted the array at first. After that we have declared the I and j, that is this one right here. I and j have been declared. All you have to do is just declare I and j as the middle element and the jth element as the last element. That is, let's just say if we have 1 2 and 3, what do? I stands here in the middle, and j is standing here. And what if we have even elements? J is standing, I is standing here, and j is standing here. J is standing at the last element, and I is standing at the middle element. Fine. So this is the whole part. Nothing too complicated. We declared a count variable. After that, we come into the loop part. So loop part, as we declared that if we are forming a pair, remember, nums of I is -1. As we said that if something has already been made a pair, that is, let's just say 1, 2, 3, and 4. 2 and 4 have already made a pair. We declared it as -1, right? We changed its value to -1. So if we come across a index where the value is -1, what do we say? You move back from that index. Fine. So this is what we have done right here. And also, if let's just say I and j both are standing at the similar position, let's just say j is right here and I is also somehow here. Can it make a pair? Obviously not. I has to go back, right? I has to go back. So that is why we just wrote that if the value is -1, or if both are standing at a similar position, I should go back. And if j's value is -1, you go back again. Fine. So this is the whole part from here. Now coming on to the main part, that is we check for the condition. If the twice value exists, what do? We just make sure we add 2 to the counter variable. We decrement I and j by 1, and we mark both the indices element as -1. And if we are not able to find it, what do? We just move I by 1. That is 1, 2, 3, 4. I'm not able to, let's just say, find for this I. What am I going to do? I'm going to decrease I by 1, right? And now we can actually find it and make a pair. So this is what we have done from here. And this is it for this whole code explanation. And if you want the code, it will be linked into the description as well.